Landslides are considered natural hazards due to the impact that they have on humans and the disruption that they cause to the communities in which they occur. In New Zealand alone, conservative estimates show that the annual costs associated with landslides are between $250 and $300 million, with over 600 lives being lost since 1843. To minimise these impacts, this project investigated the implementation of remote sensing techniques, specifically focusing on the feasibility of these within New Zealand. To achieve this, there are two key objectives. The first involved developing a site selection process, and the second involved using unmanned aerial vehicle photogrammetry to collect and analyse data.
The selected case study area is located in Caudwell, which is situated on the west coast of the Waikato region in the North Island. This area is specifically known for its susceptibility to landslides. This land is mainly used for stock farming, and there is a substantial risk associated with landslides related to the potential impact on roading, infrastructure, private housing, and the environment. Of this 26 km squared area, a small section of farmland was selected as the landowner had approved remote sensing techniques on the property. The selected farm is 93 hectare block of land that displays slope instability signs such as creep shown in the image below.
In order to optimise the use of these remote sensing techniques, a site selection methodology has been developed and implemented in our case study area. This involves 4 key phases, the first of which accounts for technological limitations as well as sorts the area based on susceptibility criteria, such as elevation, slope, distance to waterways, distance to roads, soil drainage, and land cover. Following this, these criteria are weighted in Phase 2 to create a final site selection map as shown on the right-hand side of the page. Phase 3 validates this map by overlaying the results of this map over aerial imagery and investigating the relationship between the results and evidence of instability such as creep. The final phase evaluates the selected sites based on limitations that are unable to be assessed in the previous phases, such as property access and appropriate drone flight conditions.
The remote sensing technique utilised for this project was unmanned aerial vehicle photogrammetry. This involves flying a drone over a selected area and capturing a series of images at different orientations and locations. The 3 km squared area was covered in 11 minutes and 13 seconds, which resulted in an obtention of 208 images. These images were then pieced together in processing to form digital surface models, which can be seen on the right-hand side of the screen. The digital surface models produced from a range of data collection days can then be compared to determine any slope movement occurring at the location of interest.
Overall, the site selection methodology was successfully developed and then implemented in the Caudwell case study area to identify preferential sites for monitoring. The selected site was monitored and the results were sufficiently accurate as indicators of slope instability were identified. This proves the feasibility of this process and indicates the potential to be further implemented in New Zealand.